Today, we want to introduce the idea that we secretly introduced yesterday. That is the derivative of a function at a point. The derivative at a point is going to tell us the slope of the line tangent to a function at a given point. This derivative business is a local thing. It's something that happens at a point. I want to find the slope of the line tangent to the function at a point. We developed this idea yesterday with an approximating secant line. And so that's where this mess came from. This f of c plus h minus f of c over h, that's just the slope between, I need another pointer. That's just the slope between the point that we're interested in, c comma f of c, and this point that's nearby, h units away horizontally. So that's c plus h, f of c plus h, because that's how we get points on the function. We plug in x values. Then the idea is to move the second point closer to the point that we're interested in, because we know that that will improve our approximation. Then we have to apply calculus thinking by making this point infinitely close to the point we're interested in. We have to let h approach 0. H is the difference horizontally between the 2 points. I want to let h approach 0. That's the second point, getting closer to the first point. They're h apart horizontally, and I want them to get closer. So h is approaching 0. And then that's where we needed limits, because it wasn't good enough back in the day when we were like, oh, let's make it infinitely close. Then they're like, oh, well, what does that really mean? I'm like, oh, quiet you, philosophy department guys. It's working. So let's see this happen. For this example, taking the role of f of x will be the function x squared. And the role of c, we're going to have 3. So here, c is equal to 3. That is the point that we're interested in. I've already messed up. I was using turquoise for the point we're interested in. Now it's red. Whew, this class is going to be much more difficult now. So the point we're interested in is where x is equal to 3. I picked that because it rhymes with c. Actually, I picked it because it wasn't 2. 1 is a lame choice, and 2, there's already a 2 in the problem, so it's got to pick something else. So I just kept going down the line of integers. All right, so I want to find the derivative of f at x equals 3. I want to find f prime of 3. So to do that, I'm just going to use my definition up here. F prime of 3 is the limit as h goes to 0 of f of c plus h. Now remember, f of x is x squared. So f of 3 plus h is just 3 plus h squared. And f of 3, that's the other piece that we're going to need, is 3 squared. Those are the players in this little drama of the definition of the derivative at a point. So I'll take the limit as h goes to 0 of 3 plus h squared minus 3 squared all over h. When we're evaluating limits, what we want to do is plug in the value that we're interested in, but we can't here because that will give us 0 over 0. And we can't say 0 over 0. We don't know which 0 over 0 we're talking about in this case. So we're going to have to do a little bit of algebraic manipulation, push some symbols around the page, hit it with the algebra stick for a little bit, and see if we can get rid of that h, which we should probably guess that we're going to be able to do because that's what I just said our plan was. So, spoiler alert. So what we're going to do is some algebra. We haven't done this limit business yet, so that's hanging around. We have to keep writing it because we haven't done that yet. 3 plus h squared is, let's see, 9 plus 6h plus h squared. 3 squared is 9. And now we can see that h on its way out. Some of you see it now. Some of you are like, oh, wait a second. I still don't see the h disappearing. So we'll take the limit as h goes to 0. Now notice that I've got 9 minus 9. So these we can get rid of. And so all I have is 6h plus h squared over h, out of which we can factor an h. What this has done for us is gotten rid of that problem h in the denominator. Six plus h is continuous. Our original was not continuous at 0. It was undefined at 0, but 6 plus h is defined at 0. So I can just plug in the 0. We employed the same strategy that we did yesterday when we factored and canceled out the denominator so that we could just plug in the point that we care about. Any questions? Algebraic, sleight of hand. Nothing up my sleeves. Is that okay? This is using the definition of the derivative to find the derivative of a function at a point. This is something that we want to phase out as quickly as possible. The point of being in a math class is to not have to do all the friggin' math all the time and just understand what's going on. Like all those algebra, all that algebra training was so you wouldn't have to think about the algebra so much anymore. So let's train. Any questions on this one? A little bit of algebra. Remember the thing from yesterday. We want h to equal 0, but we've got to cancel out of the denominator so we can just plug in the h. We just have to make something happen algebraically. In this case, multiply stuff out. That's how we deal with polynomials. Right now, everybody's like, oh, we're not listening. You said something about a shortcut earlier. Like, well, keep pretending to listen, and we'll get to the shortcut. So let's say that g of x is 1 over x squared. Let's find g prime of 3. So interested in the same point, but we have a new function. Now our function will be played by the role of 1 over x squared. So g of 3 plus h will equal 1 over 3 plus h squared. And g of 3 will be 1 over 3 squared. These are the parts that we need for our definition of the derivative. Those of you who have secret calculus knowledge, yes, we will be writing this as x to the minus 2 soon enough. And then just do minus 2 x to the minus 1. So g prime of 3, we want the limit as h goes to 0. This is going to be messy because it's going to make a compound fraction here, or a complex fraction. So g of c plus h minus g of c all over h. Man, I really wish I could evaluate this limit by just plugging h equals 0 in, but that h in the denominator is messing up our plans. So we've got to cancel it out. We're looking at this h down there and say, you are being a problem, so you have got to go. So we're going to do some algebra. I've got 2 fractions up in the numerator. I'm going to simplify that and see if I can cancel out the h, which we know we're going to be able to do because that's kind of the whole point of these kinds of problems. It's very contrived. There's no surprises here. So I got to combine these fractions. I'm going to do a little bit of algebraic sleight of hand. See this all over h making our fraction super tall and kind of annoying? I don't know if you're annoyed by these kinds of things, but I am. So instead of dividing by h, I'm going to write this as multiplying by 1 over h. Dividing by h is the same as multiplying by 1 over h. Thank you, algebra. That's very useful in conserving vertical space. That's all that's going on there. Let's see. I got these 2 fractions and I'm going to add them up. So my first fraction has a denominator of square of sum of 3 and h. My second fraction has a denominator of 9. So my first fraction I'm going to multiply by 9 over 9. And the second fraction, I'm going to multiply by 3 plus h squared. And then our denominator I just added those fractions. 1 over a minus 1 over b is b minus a over a times b. Get a common denominator so that we can add the fraction. We only add things that are the same, and when we add them, it doesn't change what they are. Sameness in fractions is the same denominator. Thanks, algebra. That was helpful. I'm going to simplify the numerator because we know that that's going to produce a factor of h because we just did that in the previous problem. We know that there's going to be a 9 cancels out that numerator. That's going to leave the 6h plus h squared. That will cancel out the h that's causing us so much grief with our limits. So let's multiply out the numerator here. We still have not taken the limit as h goes to 0. We're still waiting on the ability to do that. I still have this 1 over h. I haven't canceled it out yet. But this is going to be 9 minus the 3 plus h squared is 9 plus 6h plus h squared. The denominator we're going to leave as it is. We're going to leave it written in that weird order that I picked. Now we can see the 9s canceling out. And that's why h is going to become a factor in the numerator. This 9 minus 9 will cancel out. That leaves 6h plus h squared times -1. And I'm going to factor out an h. The denominator, I'm going to keep leaving alone. And now the thing that I wanted to happen can happen. That h from the denominator that was preventing us from plugging in 0 has now been canceled, just like in the previous problem. Now these h's can cancel out. Just like up here when these h's canceled out. So the negative was already there, right? There's that negative. That's the negative. And then what's left here is 6h plus h squared. So I factored an h out of there, leaving the 6 plus h. I wanted to factor that h out so I could cancel it. We could cancel it out without factoring it out, but we'd have to remember to take an h out of both of those terms, which is what we'll tend to forget to do. So we're just being careful. Now that I've canceled this h, I can go ahead and let h equal 0. Because h is 0 here, that's not a problem because it's 3 plus h squared. So now we can let h equal 0. So I've still got this negative. 6 plus h is just 6. And in the bottom, I've got 3 plus h, 3. 3 plus 0 is 3. Squared is 9 times 9 is 81. Questions? I think that's earlier I said minus 2x to the minus 1, and I went the wrong direction. It's minus 2x to the minus 3. This is because I spend much more time teaching Calc 2 than I have teaching Calc 1. So my default is integral instead of derivative. Apologies. If you didn't know what I was talking about there, that just means you don't have the secret calculus knowledge, and it's okay. That's what we're trying to acquire. Is everybody okay? I can cancel a 3 out of here. How's everybody okay? How much calculus have we done today? Almost none. Because the only calculus part is that we're writing limit all over the place. So it like has calculus trappings, but we're trying to deal with this limit by plugging in the number. So try to make it easy on ourselves. Learn more about function. Pre-calculus is your advanced algebra class. I don't know if you remember, some schools call your first algebra class elementary, your second algebra class intermediate, but then they call your third one pre-calculus. So you're wondering, like, why intermediate when it's not in the middle of anything? How's everyone, okay? How are your algebra skills? Good? Everybody walks into calculus with algebra deficiencies. They're just different depending on what your algebraic history is. No one walks into calculus with a full package of algebra loaded and ready to go. Mostly because you haven't even been exposed to a full package of algebra, because it would be unreasonable to do so. And that's okay. It's okay if you're a little bit shaky on simplifying rational expressions. You're not supposed to be experts at it. It's not really an important skill moving forward. Like if you're at a job in the future as some engineer, and you're about to find the derivative of a function by hand using the definition of the derivative, you're probably about to get fired. The boss is going to go, what are you working on? Like, I'm about to use the definition of the derivative to find the derivative of this function. And they're going to be like, I'm going to need your badge and clean out your desk. That's ridiculous. That's a $10,000 computer sitting on your desk, and we've got $1 million in computer time booked. I don't want you doing that by hand. I want you understanding the concept so you can do more complicated things. You know what I mean? Unless, of course, you're like a math teacher. I need to know how to find derivatives by the definition. But that's a little bit each thing. And I'm not sure anybody really plans on that. I did, but maybe I'm weird. So at this point, that was a lot of algebra. So at this point, you're thinking, yeah, this is how you will actually do things if you're doing this by hand. Once again, this is not what you're going to be doing in the future in your career as a fill in the blank. Unless, of course, you happen to be a math teacher. So I did say something about a shortcut, and I was figuring out these derivatives really fast. So if you recall, f of x, when f of x was x squared, the derivative f prime, some of you know, 2x. And so f prime at 3 will just be 2 times 3, or 6. That took an awful long time just to even write, but that's how fast we can go. That's how fast we want to go. In fact, we don't even want to write all this stuff down unless I specifically ask you, what's the derivative? What's the derivative at 3? Then you can write that down. If I just said, what's the derivative at 3? For something this simple, the goal is to just say 6. When g of x was 1 over x squared, we read this a little differently. I read that as x to the minus 2. I've heard people don't like fractions. So like, well, let's get rid of fractions and just do negative exponents. So g prime of x negative 2 x to the negative 3. So g prime of 3 will be negative 2 times 3 to the negative 3. That's our previously discovered 2 over 27. There's a shortcut for taking a function. Specifically, I'm working with a particular kind of function, a polynomial or a rational function, specifically actually a power function. I forgot the word for a second there. Yes. I have secret calculus knowledge. See, the way that this discussion usually works out is like I tell you how the shortcut works on a few examples, and then right before I explain how the shortcut works, class is over, and you have to think about it over the weekend because I don't tell you. So I'm going to give you one more example. I'm not telling you the secret. I'm just going to give you some examples. So I'm going to look at the square root of x. What's the exponent on x with the square root of x?
1/2.
1/2. I like looking at powers. This weird radical notation, I do not find it radical at all. It's ancient and weird. So I'm going to read this as x to the 1/2 power. I typically write fraction exponents side to side instead of up and down because it takes too much space up and down. I never write diagonal fractions. That just looks awful. I don't know why. But if you're like all 1/2, I'm like all, yes, that's a nice fraction. If you're like all, I like single line syntax, 1/2, I'm like all, heck yes, I like that. If you're like all, I write diagonal fractions, I'm like all, get out. I will just kick you out of class. No explanation. You'll turn something in, it'll have a diagonal fraction on it. I'm like, oh, what the hell is this? Get out. And you're like, oh, but that's the way I was taught. Tell me your teacher's name. And give me their address. I'm just kidding. I already know their addresses. Some of you know this one. Don't say it out loud. Let's confirm if your instincts are correct. I'm going to put a 1/2. See, this one's going to be a coefficient. It's going up and down. And the exponent is going to be -1/2. Does anybody have that? Who had that? Everybody's like, oh, I had that. Wait a second. Are you going to double check? No, then I had that. You might not want to volunteer for that because if everybody has that, then the test is on Monday. No. That would be funny if we did, though. So if we wanted h prime of 3, it'd just be 1/2. Oops, I spelled 3 wrong. How many x's are in 3? That's right, 0. Somewhere out there, there's a teacher that is all about the diagonal exponents, but absolutely opposed to radicals in the denominator, and they're on their way to fight me right now. Bring it on. Those kind of teachers use snipers. So let me know if you see like a little red dot appearing anywhere. I'm just kidding. They don't need a red dot site. They're better than that. All right. See if you can see what the pattern is. I've not given you a lot to go on. I've told you there is a shortcut to all that algebra business. So you're highly motivated to avoid all that algebra business because this looks a lot shorter. So see if you can see what it's like. Make a hypothesis about how it works, and then check your hypothesis on the internet. That's it for today. That's it for this week. I'll see y'all on Monday. Everybody have a good weekend. Thanks for playing.